aspects of mobile AR. So this is the mobile AR is augmented reality, right? So you see there is a picture here. You probably have used similar services before, right? So those glasses, those are virtual glasses, right? So these usually are stored as a 3D dimensional asset that you could then package with your mobile application, for example, in this cases, right? So you could use things like Snapchat or Ray-Ban, those are or Warby Parker, those apps to try on various type of glasses that you think you might want to purchase, right? So this is an interesting use cases of the AR. So yeah, so basically we want to be a little bit more sort of technical about what ARs are, augmented reality, and everything that is sort of trying to merge the physical world, which is in this case is the human space, right, with the virtual digital rendered asset, right? In this case is the glasses, then those are by definition and augmented reality. Right? So like I said, you probably use it before, you use Snapchat, right? And then those are things that you have encountered, right? So what do we do, right? So for this particular case, right? So what we're interested in doing is we're trying to think from the perspective of the AR application providers or designers or developers, right? So how do we actually make sure the user, everybody who use those type of applications will have good experiences, right? So what I mean by good experiences is if we take this virtual glasses panel as an example, right? Good experiences will mean that the virtual glasses rendered are very realistic, right? So they look like the physical glasses we're wearing, right? So not just like something that just pays to your face, for example, right? So that's a realistic aspect. So those are rendering, right? And then other example will be when you turn your head around, right? So the glasses should follow your head, right? Instead of just trying to flow in a space. So that's not a good experience for the user, right? So those are tasks for you have to track the users as post tracking. So those are post tracking tasks, right? As well as be able to figure out exactly where on the user space that you need to put on the glass. So those will sort of involve a little bit of 3D face mesh modeling, as well as a little bit of gas estimation, meaning you need to know the distance between the phone, which the user uses to try on those virtual glasses. Right? So those are the tasks we're interested in providing to the AR applications in order to provide a good user experience. And so that's the high level idea about the project. Right? So for this talk, I'm going to focus on one aspect, which is the lighting estimations, right? So lighting estimation basically just means that we have lights, right? That's how we see things, right? So in the physical world, right? So in order to render the virtual objects very realistically, we need to apply the same lighting conditions to the virtual objects, right? But how do we actually extract those information and use that lighting information to render the assets, right? So that's what the lighting information actually is doing. And later you will see this is actually a well-studied but also still quite challenging task because trying to extract the physical lighting information, can be tricky given the mobile devices hardware limitation, right? So you could of course do all this with a very, very expensive setup with thousands of dollars of cameras and stuff, right? So, but that's not the goal, right? So we want to support the commercial mobile devices to do similar rendering. So having said that, right? So one of the things I want to point out that you probably already know, right? So when we talk about problem, right? So one thing that we want to think about is how do we know we succeed, right? So how do we know that whatever problem we put forward is that we actually solve the problem, right? So that comes to the metrics, right? So we want to have a way to either quantify some, aspects we're interested in this case that I talked about earlier, we're interested to see, hey, how realistic the glass is rendered, right? So that will be the visual quality. there are metrics we use, right? So it's okay that you don't quite know those metrics yet, but one of the common one is the image-based metrics called PSMR. Basically, that just measures the noise in the images as well as how similar two different images look, right? So that's the goal. So we want to achieve as good rendering as possible too, as if the user were wearing the physical glasses that look the exact same. Right? So that's a visual quality. And other interesting metrics we are also sort of always considering for systems work. Right? So that's what I come from. Right? So I do a lot of work that's trying to make things run faster. Basically, that's like one way to understand that. Right. So for this particular application cases, we're interested in to reduce the time to render the assets. Right. So really that process can be very time consuming depending on how many sub-tasks you need to do, right? Post back and like, right. So we want to reduce the time on that. Okay, so that's the AR aspects. So I'm going to give you a little bit information about the various work we did in the content of lighting explanation, right? So with the goal to sort of talk a little bit about three different lessons we have learned over the years that we know experience, right? So I'm going to use those words as sort of the introduction to those three observations we have made and various techniques that we actually use to solve things that empirical system research, right? So how do we make things? How do we actually handle various things like noise? Okay, so this work is one of the work that we don't really brief. This is the work that you can see here. This is the virtual rendered crumble. This is one of the commonly used assets people use to trying to figure out whether you have a good understanding about lighting. Okay, so if you have a good understanding about lighting, then the reflection should be realistic, right? So be able to reflect what is in the physical environment. In this instance, is that for the mass what we have. Okay, right. So the project with AR, we'll talk a little bit more later, but sort of a long story short, right? So this is where we're trying to, for the first time, providing a real-time reflection support for mobile AR. Right. So the problem scope is very important, right? So we are not saying that we're the first to do it for render reflection because that's not true, right? Because reflection can be supported in game, for example, like video game that's based for reflection. But those are very different techniques. Ours we call real time in the sense that everything has to react to how the user reads to the camera, right? So for games, for example, you have a little bit more leeway because you can do offline processing when the game is under all right, so that's one aspect. So if we have time, I will talk a little bit about the second word that's the symbol event, right? So if you know what lighting estimations are, again, right? So this is the task we're trying to understand the physical light condition. And you sort of think about it, right? So in addition to the reflective surface we need to report, there's also other materials like more diffuse material like my clothes or like Jane, right? Those are really require very, detailed lighting, that's put it that way, right? But because they're not reflecting anything, they just have those more diffuse feeling, right? Those are called diffuse material, right? So this is actually the first what we started. So we were trying to think, how do we actually support diffuse rendering in the sense that, right? Thing that does not require reflection will also be correctly and coherently rendered. So those three are virtual assets. So you might wonder why do we separate those tasks to different aspects? A lot of time it comes down to, hey, we can't really solve the problem in one single project, right? So it's really a bigger problem. We kind of have to divide and conquer, right? So the way we divide and conquer is that, the lighting really has two different major ways to present it, right? So we want to see whether we can start solving the easier one, which is this one. And then the reflection is a lot more difficult. Right? So by the way, feel free to interrupt when you have questions. Raise your hand and I was trying to make sure that I see you, right? So I probably will see you, right? But that's the thing, right? So AR. Okay. The second aspect of the word that gives a little bit flavor is called distributed deep learning, right? So how many of you have heard of deep learning? Yeah, so many of you, how many of you have used deep learning before? Yeah, fewer, right? But it's still good. Like everybody heard about deep learning, right? So this is like in one of, I guess, people consider it as a very important techniques or things that happen in the past. Right. So, well, what are our work about? Right. So we're really focusing on aspects that will allow us to train deep learning model. Right. So if you know a little bit about deep learning, you know that in order to train deep learning model, those models are very big. They will usually report a lot of data. Right. So for example, if we talk about image classification, right, then you would need tens of thousands of images that say cat images, right? And then use those images to train a classifier that will tell you that whether there is a cat in the images, for example, right? So very computation intensive, and it really comes down to how complex the models are, right? And one thing that we need to sort of step back and think about that, even though right now servers, right, so the machine itself, they're getting a lot more powerful over time. So meaning that we have a lot of GPUs that you can attach, let's say, 4 GPU and GPU cards, right? GPUs are the device that you use to train the model, right? So you can attach 4 or 8 different GPU servers, and then you have a very large GPU RAM to work with, which is, you can kind of think of them as a workspace to actually load the data in, load the model in, and start working on the model, like learning what kind of way that model has to have. Even so, right? So if you follow the news, then you know that models are getting bigger and bigger. The problem that the scientists are trying to solve with deep learning are more diverse and requires a lot of computation powers, right? So that's where the distributed deep learning comes in, right? So the way to think about it is instead of having one server, right? So like my computer can train one model, but it might take 10 days, 100 days, depending on what model you're training, right? And then we want to take that and split it past to, let's say, 100 different servers or 100 different computers. They are all connected through the network, right? And that way you can train things much faster, right? So it's kind of like, we have a big task here, everybody is usually referred to as a worker. So in the training perspective, and they're working together to achieve the final goal, which will plan the train model, which will help you to do whatever the task you are doing to do in like task. So that's distributed deep learning, right? Again, right? So those things that we're interested in is not just usually accuracy, right? So accuracy, the way it really just means that depends on the task, right? So accuracy can say, well, if I give you 100 images, right? So 90 of them are cats, and then if I give this 100 images to the model, how many times that model will say there's actually cat images, right? Right. So ideally, if the accuracy is 100%, right, and the model will very correctly point out that 90 of the correct images has the cat, right? So that will be perfect scenario, ideal. So that will be 100%. Right. But usually currently there's very few who have not heard any model that can do that kind of high accuracy, but at least the goal is that you want to be a human expert. The human can do, let's say, 87% or 97%, whatever. Right? So, and you want a model to kind of approximate the accuracy. Okay. And of course, there's other metrics like time, which in this case it just means how long does it take us from the moment we load the model in until the model actually will be able to produce with accuracy. So how long is that time? Right. So one thing I want to point out that, right, so when using deep training, that means that, right, so let's say if one machine takes 10 hours, right, so ideally, if we use 4 machines, then it will be like, okay, it will take 2.5 hours, so because we divide the work, right? And then, if you use 10 machines, it will be like, I can get it without 1 hour. So that's a whole, right, so that is we really consider upper bound of performance. Unfortunately, in real world, right? So there are overhead that is trying to use more machine because they can talk to each other, right? So those overhead make it harder to do the linear scale we just talked about, right? So usually you do like the machine probably still take 2 hours to achieve the same accuracy, right? But we just might still good depending on what the research and scientists goal are in training the model. If they don't have time, they don't have time to wait. They rather spend more with this class and that. That's kind of the high level type stuff, right? So there are a couple work that we did in this particular space, just to give you a little bit sort of idea, right? One of the things is we talk about, right, is really training. You might need to have like 10 GPU server or 100 GPU server if you have to train very big models, right? Those can be very expensive, right? If you kind of think about just take a recent GPU like 3090 GPU for NVIDIA, we have those in our lab, right? So those cost around $1,800 before you know the supply and demand kind of vary, and then sometimes it can be almost $100 per part, right? So if you want to buy 100 of the, you know, suddenly we don't have enough money in our lab to purchase it on those. So having said that, right, so how do you actually realistically use retraining, right? So one of the things is that you would use it in the cloud. So basically, right, so have you guys heard about cloud computing before? Yes, okay, so you not, right, so that's good. So if you have not heard about it this time, right, so it basically is a good way for you to not purchasing the actual physical hardware, but rather you want to rent it. Right, so like instead of saying, oh, I want to spend $10,000 purchasing a server, right? I'm going to just spend $2 per hour to rent a GPU server until I finish work and I can return the source to the cloud. Right? So those particular work I'm trying to, what we're trying to do is we're trying to help the machine learning and deep learning practitioner to make the choice about, you know, under what circumstances it makes sense for them to choose a special type of cloud server called transient server, which essentially is a very, very cheap cloud server, right? So you get a same deal in terms of computation capacity as any normal cloud server, but those are sold at a discount for the habit of the cloud provider to take the resource back at any time with very little notice. For example, right? So what we're trying to do and are interesting finding out is whether it makes sense, even though they are going to be what we call revocation when the cloud take back the resource. Even though they're revocation, does it make sense? Or would it speed up training if we were trying to use the server, right? So the short answer is yes, right? So because based on our study, this is for 2019, right? So 3 years ago, it really depends on a number of factors, like, you know, how often does the server get taken back, right? And also what is the cost ratio between the difference between the training server and the normal server. But overall, what we found is that it's actually a lot cheaper to use training server, which is by definition should be the case, right? But then the good thing is that since you save a bunch of money for only paying the discounted price, that means you will all have additional money to pay for additional resource. Therefore, you can increase the training much faster, or like 5 times. Right. This is the follow up on that, right? So the first work is one thing I want to point out is that there are usually 2 places of work that as a system research we do. One is empirical research, like system research, meaning that we observe how the computer system works and what kind of performance they have. Right, so how can we use them better? Right, even observations. And then second flavor of work that we usually do is, you know, even that we know how the computer system works in this case, how does the distributed training performs on the Pinson server, right? So can we take those insights and try to do predictive service, meaning that can we actually say, well, we have observed 10 different models that works well on 2 types of GPU server for this particular setup, Pinson server. you did give me a new model and a new GPU, you know, can I tell you that, you know, whether it's going to be beneficial or not? I said, you have to service. I want to provide to you. Okay. So those are the goal of the service. Right. So last but not least, right? So there are the work about. So if I kind of like step back, right? So the one thing that I want to say is for the pre-training work, you're really just trying to make things easier for deep learning practitioners. How do we actually make the process of training easier for people, even they don't have a computer science background, right? They can still use deep learning in their day-to-day life, right? So one of the recent efforts that we did is we're trying to, instead of having people or users rent how we can use, right? So what we could have them do is just trying to interact with our framework, which underneath will be interacting with a serverless framework, right? So if you have not heard about serverless, this is fine. You know, we talk about their server, right? So server is usually called server full paradigm, right? So we work at an abstraction of server. In the serverless cases, most of the time, we don't follow users to understand and know there are 10 or 100 servers how many users are working on the task that you submit, right? So rather, they just need to submit the code and then use the training script, the training deep learning model to this framework, right? Serverless framework, right? So then they can start training the model that way. So that hopefully will be an easier way for people who doesn't have to do science background to actually start using. Right. So it turns out there's a lot of challenges in trying to support this big training in the current servers platforms for reasons such as serverless. The serverless usually are called service function, the workers. They're usually resource constrained. It's not your normal servers anymore, right? So therefore we have to go through a lot of hurdles. But anyway, so those are the three different type of work that we did in this really training aspects. Again, always the goal to, make it easier to use, but speed up whenever we can, but at the same time, want to make it as cheap as possible so people can start more willing to use the power systems. Okay, right, so that's the high level for the gist of that. Right, so I said that, the reason I want to sort of give you an overview of this work is that I'm going to talk a little bit about the 3 lessons we learned across all of the work. Right. So I have a question here. What's your name?
Nevin.
Nevin? Yeah, Nevin, yes.
I was just wondering if the idea of the study was that the latency between having a local server and then having a cloud server, or is that a minimal impact on the time of those computing?
Right. Okay, that's a great question, right? So if let's put that question into 2 parts. The first part is that for our study, it doesn't really play a big impact because our workflow are more batch oriented, meaning that users submit a work. It would take a long time, let's say a few hours for you to actually train a model until the results comes back. Right. The scenario we're considering that users are not uploading data in real time, or data is already uploaded, right? And then you start the training, right? So those are bad ones. But the point about network latency is important for all the interactive workflow. Like for example, you want to use a cloud server to post websites, for example, right? So then latency becomes an important thing because there's usually to sit there and kind of click on things, right? So now the latency is kind of like upper bounds of how snappy your website is. Right? But third point to that is, last point to that is, if we consider the scenario that user had to, send data, the training data to a web service that help them train models, then I would still think, bandwidth might be a more determined issue because you have to send 100 GB of data to train, right? So latency is only the first initial handshake part that takes, let's say, 500 milliseconds. Even that was an exaggeration, right? Even if it takes 500 milliseconds, in grander thing to upload 100 GB of data is still very small amount of time. But does that answer your question?
Yeah, and I guess as you said, it's cheaper to be able to actually train the model itself faster than to think like operating at the time for operating data.
What do you think that offset the time
Like,
for data?
It takes less time for the model to be trained.
Okay.
compared to what we have.
Oh, yes, I see what you're saying. Yes, the total time, the overhead, you're saying, the overhead you paid that to upload the data is worthwhile to pay. That's definitely true. One thing I do want to point out that if a lot of scientists actually use open data set in Amazon's cloud provider, for example, right? So they will use those open data sets already in the cloud, or sometimes the cloud, the data upload is a one-time operation, which usually sometimes people consider one-time operation, even though it's expensive, it's still worthwhile to pay, right? So, you know, you upload one time, you can train 3 or 4 different models. Very good point. All right. What's your name? Brianna, yes.
So you talked about how like the clients or the people using these models have to input training code. Does that mean like, so they have to still know a little bit of deep learning in order to input that code into the framework? So what does the framework do then?
I see, yeah, very good questions in that perspective, right? So, to understand that, we need to step a little bit further back to the 2 different abstractions that we're talking about. The first abstraction is that if you don't use serverless, right, so you would then have to manage a class of the server, right? Now we need to ask a deep learning practitioner now to think about, oh, how many GPU I need to provision, we need to request, right? And then how do I connect them? You know, do I use RDMA, which is a very fast way to connect them, or do I use that, right? So, and you know, things like and other various aspects like what kind of a GPU type I need to select, so on and so forth. Right. So basically that's the first abstraction what we usually call the resource level, right? Or if you kind of map back to the cloud single, that's called infrastructure as a service. You kind of have to manage the infrastructure yourself. What serverless really gives you is that you don't need to consider all that, right? So those are all done automatically based on the workload you submit. In this case, the workload is running a training model. You can say, oh, here's my script. Right now, you can take it to find a cost-efficient way to configure, you know, whether I need 1,000 different workers to work on this, or you know, how many rent do I need to sign? Thank you. Yeah, of course. Any other questions? All right, so okay, so that's the overall idea. So I guess one of the things that we kind of encounter when doing all this work, which is like maybe very, very obvious, but when we're actually doing the work, things are actually not obvious in terms of how we actually handle various challenges. The first thing that we actually encounter a lot is noisy data, right? So what does it mean, noisy data, right? So in our cases, it can mean multiple things. The noisy data can mean that it is actually hard because we don't control environments like the cloud, right? So when we're trying to measure and understand how a computer system works, right? Remember I told you one of the aspects is the empirical measurement work, right? So when we're trying to understand how things work, the more index that comes to how do we make sure our observations actually are what the real system performance are. So those are noisy. Your measurements can be really noisy, right? So but we don't have insight to the black box of the cloud provider, right? So that's one aspect, one of the examples. The second example of the noisy data we usually encounter is the input data can be very noisy. In these cases, I would take mobile augmented reality for example, right? So the key input to AR is the camera feed, right? So how when you should use their backward facing camera to point towards a physical space, right? And the camera's FOV, the field of view, sees what the physical words are. So those images, if they are not at of high quality, so for example, if they are blurry, whatever, right? So those could impact the downstream task. In this case, make these things really challenging to sort of get this right. Of course, right? So those are usually more of issues if you were talking about empirical system work, meaning that we actually deploy the system to the real life and trying to interact with a very complex ecosystem that's out there. Some of them we don't have control, some we might. For example, the mobile devices, when we do have control, we can have some blurring techniques that when we develop the techniques to be deployed to the app at the same time. But we kind of have to solve the problem too, right? That's one aspect with the data, right? So the other thing I want to point out is if we kind of think about some more theoretical words, so those usually can be I shouldn't say overlooked, those can usually be handled by making it part of assumption, and you say, well, if we given a set of images, right? So they are perfectly taken, those are curated, and how do we actually learn the lighting from those set of images? Right? So then we don't have the problem about when we do that. Right? So just to give you a quick example about the noise data, what does it actually impacts and the visual of that, right? So like say there are camera view, the input to the camera is the main input to the AR, right? So if you have slight movement in your phone, right? So what happens is that on the right side here, we have a 3D representation of the same space. So your camera can only see as long as it's view of a physical space, right? But what I have not tell you yet is in order to understand the physical light information, one common techniques you are usually need to start. The one common goal you need to usually achieve is you need to have a 360-degree representation of the physical environment. Very interesting. Reconstructing the lighting. Take this room for example, right? So what I would need is from this position, this would be considered as a rendering position. If I want to render something here, where I stand, I would need this 360-degree capturing from this direction. One way is you can ask users turn around for 360-degree capture that. That will serve as a pretty good input because then you will know exactly what each part of the room looks like and so on and so forth. Of course, there's the other part because the vertical FOV is not 180, right? So you kind of have to like also kill here and kill there, but you get the point, right? So you need a full capture of the room. Like I said, right? So those are not impossible to do if you ever went to a recording studio for movie special artifacts, special effects. Right, so they usually have capturing with various camera in various parts of the room, right? So that they can simultaneously take those images and stitch them together. The way to combine those images possible, right? But like I said, right, so in our cases, we only have limited field of view to work with, and a mobile camera is usually the current one. Even the one with very large FOV is still 120, roughly around that range. Right. So you can see that it's kind of challenging to be able to just capture a 360-degree of the representation. So what we're trying to do here is we're trying to reconstruct what the room looks like as much as possible based on the past observation of the camera view 1 to you can easily imagine it can be all the way to end camera views that user use their camera throughout the temporal axis, right? So during the entire usage, right? So here 3D just means that every pixel color, right? So the pixel, rather than just having RGB, which is the color value, will also have a 3D coordinate in the sense of where exactly this color value in the workspace are. So those will give you, by having the RGB and SYZ information, then you will be able to correct, more, I would say, more easily reconstruct what the three dimension of the room is. So it's not just a flat 2D of the image. So that's kind of the idea here, right? So one thing that's challenging that we found is if you don't have any noise canceling or chorus capturing, right? So you just let user capturing whenever they're using that. What's happening is you're going to have issues in terms of trying to merge different points together. Those points, those are supposed to belong to the same coordinates. That's why it's big in the 3D space, right? So basically what is inside is red box, right? But then, because the device tracking, meaning that when you take the image you want to, right? So your device also has the work position, like where exactly this device in its workspace are. Those tracking information can be a little bit noisy if device move a little bit too rapidly or fast or whatever, right? The currently. So then therefore, when you use a noisy device location to represent and map them into the pixels for each camera view, right? Then you'll have those incorrect alignments. Okay. So that's a problem, right? I don't need to tell you how to solve it, right? So but sometimes when we think about project, and I really tell my student, right? So understanding and finding the correct problem, to identify problem is actually 50% of the way there, right? You really need to understand yourself and the problem, not just working on something that doesn't really need to, and then which sometimes you can go into that, other tasks. But anyway, so that's the problem we're trying to solve. Okay, so in order to solve the problem, right? So what we have done, what we did is the following, right? So because we observed that the incorrect alignment happens when the devices are moving too fast, right? So if the devices are moving when they're static, and then you take the images, which is intuitive, and then the image quality is good, and then give the time for the device post tracking algorithm to work, so we will have a more accurate representation of where the devices are. So if that's the observation and insight, what happens is that we're trying to have a way to detect when the devices is static or more static rather than static, right? And also the duration after it becomes static, right? So that's when we want to start taking the pictures for the images. So that's very simple technique we developed. Basically, right, so what we did is that we're trying to read in the accelerometer sensors inside the phone that will give you the reading in terms of that's why you need to see whether the device is actually moving right now. Right? So it's not, right? So we wait a little bit and then we automatically capture that. This means that we just copy the images, to our application's memory region, right, from the active camera. Right, so that's the high level idea. Okay, right. So there are more sort of subtle considerations we have to think about. I don't have time to go into the details, right? But the good thing is that because our works are all funded by National Science Foundation, they are all open source and public, and if you're interested in, you can always go on our website. We have all the code and okay, so that's the high level idea. Right. So there are other things that we have done that will actually also help with the noise capturing perspective. I'm just going to briefly talk about them. This is more, I would say, a little bit off my main research topic, but this is more like a nice add-on of human-computer interaction aspects. Right. So if you have used any AR sample apps, you will see that there's usually a sort of the on-screen instruction of saying, well, you have like move your phone around a little bit, scan the environment, and therefore you can start placing objects for you. Similar thing here, right? So our goal in designing this, what we call a guided movement, is also an on-screen instruction for the user when they launch the app that developed using our framework, right? So you can think of our framework provides a bunch of APIs that developers can use, right? So then they were telling users to do the following, right? So those are ways that users should scan the environment with the goal to increase the observation of the room. Remember I told you, right? So the goal is we hopefully want to have a 360-degree view of the room, right? Where we place the objects. So things like that, and also things like, instead of asking users to turn around 360 degrees, right? There's actually interesting things is that you can do things like, oh, hey, use this, and you turn. Well, if you're like, this is actually silly, but then, as I said, right, so this is a simple thing that we came up with, and actually much easier to do than have user to, fix one thing and trying to turn around without moving, that's not much harder, right? So, simple things like this. Yeah, anyway, right, so I think given the interest of time, I'm going to, go to there's, a little bit other things that we have to do for noise data in terms of measurements. But, right, so those, I guess I can just have one sentence summary of that. And really the key is we have found that, you have to run repeated measurements if your environment is noisy. A pretty good example is the interesting to understand what the network performance are, right? So how fast we upload things, right? And the network is to share resources, right? So how do you know that what your measurement is representative of the network performance? So the way is that you have to measure them repeatedly, that say for 10 times, right? So the number of the times will depend on how much variation you observe. Right? As well as we probably want to measure them at different point in time to account for the temporal variation. Right. So that is a good sort of a segue to this second lesson we learned, right? So variations, right? So like I said, right? So temporal variation is actually very interesting and actually very hard to handle because once that time frame passes, you don't really have a good way to go back in time to review the measurement for understanding what exactly happened in the past, right? A lot of times people settle for if we measure the things in a very small window, right? And hopefully, right, so the time window that say is only 5 seconds, right? And then you do an average between the measurement of 5 seconds. Hopefully that's representative of we make the implicit assumption that nothing has changed in 5 seconds, right? So therefore all the variation measure is the system performance variation, not something external that happens that causes the differences, right? So that's temporal variation. There's also spatial variations, which is a little bit easier to handle. We'll talk a little bit about that. But in our cases, we kind of think about the cloud spatial variation. This usually means that the performance at different data centers, you can have one in US East, you can have one in US West, right? So those performance from a user's perspective could be different, right? But then in order to understand that, right? So the usual way that you do is you want to get rid of the temporal variation, meaning that you want to launch the event at the same time, in the same vantage point, right? From Massachusetts, for example, to the 2 different places in the measurement step. Okay, great. So in terms of the temporal variation, one of the examples that I'm going to show how we actually counter temporal variation is a very classic one, which is called record and replay. Okay, so really the key idea and insight is very simple, right? So we can't really go back in time, but mainly we can just record what happened basically in that particular moment, right? And in order to understand how various different algorithms works, even the same condition, right? So we just replay what we have record and plug in different algorithms. That way we have a very, at least as faithful representation of the environment as possible for people that you can have. That's what we do here. So in particular cases we did is we're trying to understand whether, this might be a little bit too detailed, but what we're trying to understand is what this particular framework, right? So the framework for predicting diffuse lighting, right? So whether given a condition, one of our algorithm, which is trying to skip an estimation, right? So whether it is sort of useful or beneficial to skip, right? So you can easily see like why reporting in this case is make a difference, because in order to say speaking or not speaking is right or wrong decision, you kind of have to give them the same environment to make that decision on, right? But then if you apply an algorithm to say, for this particular environment, I want to skip, you really don't know what the ground truths are, right? So therefore, you will not be able to understand what this algorithm is about. But anyway, long story short, right? So report and replay is not a sort of the thing that we come about. So as I said, is widely used in system research to create a fair and common environment for various system techniques to be compared against, right? So this you can kind of recognize the sandbox, right? So now you have something you can use. In this case is right. So we just report an AR session, which use it to serve as the ground truth of the lightning. So next we're going to talk a little about the last one is the reliable measurement one. Okay, so I said, right, so this one actually comes in quite tricky for things we don't control, right? So AR1, the line of AR we did, it is still tricky. We have to sort of vary a lot of different variation, like the number of device, the type of device we use, the network configuration we use, and you know, the type of the environment we use, and so forth. But really, the good thing is we do control all of this because we can still be able to vary the configuration, right? But in a cloud setup, right? So things is a little different. In particular, I want to give you an example from this particular word. Right. Recall that what we are trying to answer in this particular work is we're trying to see whether a special type of cloud resource offering called MCN server is it actually beneficial or cheaper, in this case, cheaper to train deep learning model. Right. So one of the things is that if we want to be a little bit more positive about when we see there is a benefit in cost reduction, as well as the speed improvement in training, we know that is going to be a more generally applied observation. That means that everyone else who use the same workflow and same review, they will see similar things. Right? So we want to make sure that the observation is right. So it is hard because, right? So what we can see from the cloud environment, we can only see what happens, right? So we can of course launch the discrete training workflow, and once it finishes, measure the time, which is simply measured, right? So calculate the cost, and which also can be done. But there is a bunch of hidden variables that could impact what exactly is going on with the various round of measurements, right? So one of the variables will be the workflow. Well, sorry, the workflow in terms of other cloud customers, right? So that we will all share the same. So what do we do, right? So one of the things that we did, again, this is very classic, very common techniques, right? So, and I already mentioned before, is that for things that has potential hidden variables or impact, right? So you could, one way to do that, you could actually be trying to repeat experiments, so that if you have carefully designed the experiments in a way of saying, well, those are 32 different rounds of the same configuration, of the same setup, right? So, well, same in the sense that the variable you can control as a customer, right? You don't really know where the cloud is going to allocate the variable to, right? And so forth, so forth. But from the customer's perspective, we use the same setup, right? So, and then we measure all those particular metrics we care about. And then hopefully, right, so if you measure enough, right, and then in the ideal cases, you will measure, 10,000, 100,000, and so forth. hopefully that distribution will be, a closer representation of what the actual distribution of the people will see. But unfortunately, that's not realistic because it costs tens of thousands of dollars to run those experiments actually, right? So in these cases, and then we only do 32, the actual number can vary depends on the setup, right? But the HELO will take away the ones who repeat that, right? And hopefully that you can use the average to or the distribution to represent what you would expect to see. Right? Okay. Right. So that's the reliable method. Okay. As a quick key takeaway, right? So I'll let have some other work in security. There's faculty work on security, and there are also other type of application driven performance measurements work we do in our lab. If you're interested, feel free to reach out to connect with those people, right? And this talk and I really just trying to give you a little bit flavor of the work, and then kind of some scientific method we're trying to follow in order to make our work more reliable and results more reproducible. And one thing I will say is actually very hard in a lot of work that we did is data set. Okay, so what we're trying to do is you know, you can kind of think of the data set as we need data sets to develop our approach, and as well as we need data sets for other people to compare their work to our work, and we all have to have a common ground to develop it, which is useful. That's why we have open source almost all our code and data sets. So hopefully that will help to build this for community. That's a research about. Okay. So even though there's a little bit of time, I prepared 3 grant writings. I know you guys are already in the process of writing your grant, and I'm not exactly sure what the process are, and maybe my experience is slightly different than yours, but I'm trying to be a little bit more general here. One of the things, and I found is very useful, both from the writer's perspective as well as from the reviewer's perspective, that when the panel revealed various experiment proposals, right? And I found that overall vision is actually one of the very important aspects. In the first 2 pages, if you have not sold your vision, you have not successfully or succinctly described what impact the word can bring to the general society of the world, right? So you have not captured the reviewer. It's very hard for people to continue paying attention, which is sad but true, right? So we all humans, this is natural, right? So what I found is useful is of course reading a lot of example will help, but I would say before reading example, perhaps sitting on and writing is probably more beneficial in my opinion. And the way that we could consider writing is I found top-down writing is useful, meaning that I usually will have a sort of tree structure diagram that help me to I will actually draw the lead notes first to say, well, what techniques I'm going to, what problem I'm going to solve, what techniques I'm going to use, and I'm going to build up. And I want to have a tree in a sense. I want every component to be connected. I don't want to have separate things like, you know, they're not connected, right? So that's kind of thing. So build a tree bottom up, but when you write, you want to write top down, right? So start with the region, capture the regions, right? Right. The second thing that I found is useful is to really spend time trying to identify the good problem. And so those sounds intuitive, but what I found is but I really see that is very hard to do from my own student. And then I kind of summarize into 2 aspects, right? So the first thing is that in order to find a problem, you really need to understand the state of the art, right? So that requires reading papers, right? So I don't have time to sort of go through the paper reading technique. If you're interested, send me an email. I have slides back and I can share with you, right? But understanding the state of art is really important, because then if you know what the current thing looks like, and then you will know what you want to do, and then naturally you know what the gaps are, right? But sometimes I would see, some students attempt to, they have great ideas, they come to me and be like, it'll be great if we do this. I was like, that has been done 20 years ago, but that's a great start, right? So let's go back and read those classic paper and see, what have people push this line of research, to start developing partners, platform, right? So that's the second one. The last one. Oops, sorry. So last one I will share is to write it logically rather than chronologically. So what I mean by that is when you're trying to write, sometimes perhaps you will have the temptation to write things in steps. So like step one, I want to do this, step two, after that, I do that, right? So those are what I call chronologically, right? So, but then you could start with that, that's fine, but in the final proposal version, you would probably want to step back and try to think really from the reveal's perspective and say, do we really need to know the step by step to actually accomplish the task, or are they more interesting to know what the logical connections between each step to the problem we proposed earlier? How does that solution or step we described actually solve a logical problem? Really putting things in the context of the bigger region we like. Okay. Right. So with that, I know it is already time, but I do have two big slides about personal experiences. One thing I want to say is the following. Insert, up and down, very common. There's going to be success and also going to be failure. Those are all common. So what matters is learn from the failure. And if there's no failure, then you can learn. Okay, so just push through this. I know it's easy said and done, but as a person that goes through the 20 years and then I look back, this is actually one of the biggest things in my personality. I never afraid to fail, and then therefore I think I learned a lot. And last but not least, sometimes you might think the progress is slow, right? So you already did like 10 different things, nothing changed. Persistence is actually very important. Maybe the 11th thing you did is going to be becoming factor that you actually learn what you need to learn, right? So that. All right, with that, I'm going to stop here. Thank you so much for being here and listening to the presentation. It's our lab if you want to go to our site and check out stuff. With that, thank you very much.
Right, so our next speaker is Simon Allen. And currently you are a senior and place it, where's that? Place it and set. Yes.
It's stretching point.
What?
Okay. Hi guys, I'm Saya. I'm a senior here at MAMS. I'm probably senior around the building. So I thought today I'd talk a little bit about my project that I did last year. And then I'd end with like a couple of things I've learned from the process. And then a bit of advice that I'd give you guys. And then I think, hopefully for at least 5 minutes or so, I'd be really happy to answer questions from you guys. Yeah, and anything that you might have about, or any questions you might have about the project, if it's someone project in general. So what I studied last year was the impact of curcumin on depressive symptoms in software. So basically, the currently over 300 million people globally suffer from depression, and our most commonly prescribed method of treatment are SSRIs, or selective serotonin reuptake inhibitors. And they're based on the monoamine deficiency theory, which basically states that the lack of monoamines in the brain, specifically serotonin, dopamine, and neuroepinephrine, are the primary causes for the onset. However, these medications come with many side effects, including sexual dysfunction and weight gain, and they have very low remission rate, which actually causes nearly a third of patients to discontinue treatment after the first 3 months. So that kind of led me to the need that there has to be some other, hopefully natural form of treatment for depression, especially because our current treatment methods are very lacking and don't work for all individuals. So curcumin is demonstrates natural antidepressant properties. And curcumin, for anyone who might not know, curcumin is basically the principal active component in turmeric, which is a spice that's put in a lot of Indian food. That's actually kind of what led me to this project. My mom, when I was little, would like give me turmeric and be like, "Oh, it tastes anything." So we tested it out. So basically, curcumin demonstrates natural antidepressant properties. For example, there's studies in rats that have demonstrated its ability to increase levels of glutamate and serotonin within the brain. And it's also a natural antioxidant, natural anti-inflammatory. And I bring that up because recently, like in the past, I want to say like 6 months or so, there's been a huge influx of research that's saying that the monoamine deficiency theory, that the lack of specific monoamines within the brain can't be thought of as a primary cause for the onset of depression. Other factors such as increased levels of glutamate, high levels of oxidative stress, and inflammation in the brain can also lead to depression. So I chose drosophila melanogaster as my model for depression. I know that's like a very weird thing to wrap your head around. There are actually better models than I originally thought they were. I was pretty skeptical when I started, but they do contain neurotransmitters like serotonin, dopamine, and a neuroepinephrine equivalent called opamine within their brain. And the structure, this is probably the most important, the structure of these neurotransmitters are similar to that of humans. They have the same amino acid precursor, and additionally have similar molecules for transport. And so what I used to induce depression within these organisms is L-DOPA. For anyone who might be studying Parkinson's disease for your project, L-DOPA is the kind of most common treatment for Parkinson's disease. Is able to increase levels of dopamine within the brain. Within a drosophila, basically what that does is it creates competition between serotonin and dopamine for uptake into the drosophila brain, which will ultimately decrease levels of serotonin. And that's how I chose to mimic depression. within the top line. And then importantly, the treatment, what I was looking at, treatment with the treatment has the ability to cross the blood-brain barrier. So my hypothesis was, if the treatment is given to the top line model for depression and the prevalence of depressive disease. So I had 4 experimental groups. My first group was my control. This kind of established the regular behaviors of the top line. The second was solely treated with treatment. I just wanted to see if the treatment itself was impacting the behaviors in any way. L-DOPA was the third group, and this kind of displayed the depressed behavior. And then the L-DOPA human group, basically that was, I compared the L-DOPA group and the L-DOPA for human group to kind of see how the human might be changing the impacts that the L-DOPA was having on the software screen. So my first assay, so I'll just preface this by saying the 3 assays that I tested are all behaviors that are controlled by serotonin within the desophilized brain. And additionally, it was interesting, they're also all behaviors that change in humans who are suffering from depression. And so that's how I chose the 3 assays. So the first one was locomotion. I basically measured how the amount of movement displayed by a flyover through the setting. The second one was feeding. I measured their food intake over a 24-hour period. And then the final one was aggression, and I measured the amount of aggressive behavior they displayed for another 5 minutes. Okay, so these are my results. So many of you, if you presented your charts to your articles to Dr. Steve, you probably know a lot what's on here. And this is the averages of locomotor behavior with standard errors being displayed. And then the bars going horizontally at the top of the asterisk, those indicate statistical significance. 3 asterisks indicate a very high level of statistical significance, so a p-value below 0.001. So basically, what I found is that every single group compared to the L-DOPA group were statistically different. And then there was no statistically significant difference between the control group and the group that was treated with L-DOPA. So at least in the case of locomotion, we see that curcumin is able to reverse the depressive impacts of the L-DOPA. This is my food intake. This is the assay that measures food intake, and the results from this were very similar to one on the prior slide. Again, we see that there's a huge statistically significant difference between the L-DOPA group and the group with curcumin and L-DOPA, and there is no statistically significant difference between the group that was the control group and the group that was given, both the curcumin and the L-DOPA. Sorry, I always get like about my word. Okay. The last one, this one was aggression. This looks a little bit different because aggression is behavior to increase rather than decrease in organisms that are suffering from depression. But again, we see that the L-DOPA, the flies that were given solely L-DOPA displayed significantly different behaviors than the remainder of the groups. And again, there was no statistically significant difference between the human and L-DOPA. So from these experiments, I was able to conclude that curcumin was able to reverse these changes in behavior caused by the L-DOPA, and that curcumin alone had no impact on behaviors. Some extensions that I'd love to study in the future. I'd like to use a higher level model of organism, just because you want to get as close as you can to something the brain. A desophilized brain is pretty far from that. And then I'd also like to look at the synergistic use of curcumin and an existing antidepressant, and also use different levels of curcumin. I used the standard amount in my experiment that was found by a prior study, but I'd be really interested in looking at different levels and what might help. So here's my board. Don't get scared by this, like you guys will all get there. References. Okay, and then I just wanted to end with a little bit of advice from what I learned. So first thing, and I'm sure you've heard this from a lot of people, but definitely choose a project that you're passionate about. You spend so much time on this, and there are the days that are really hard. So as long as you have something you're passionate about, it'll give you like it'll make it a lot easier to kind of push through those days and keep going. Second one, start your experiments as early as possible. I did not, and I was here quite a lot over like December break, and I take your breaks, you guys all deserve them. So try to start as early as you can, just so that in the time that you are going to rest.
Okay, the third one, conduct extra research. I know Dr. C's 25 or 20 some articles do seem like a lot, but I will say, even if you're not documenting them in the exact way that we do in our in your logbooks, I just have to Google Doc for myself, and I might read like half an article and just pull one fact out that I felt like, oh, that would be useful to know, and then we move on. One thing that I found, the references section, sometimes you don't always need to get down to the bottom of those journal articles, but if you do scroll all the way back down, there are references that they have. And usually those are really good places to find other articles that that might have similar information or supplementary information that you might be able to use. So definitely check those out. Okay, so the next one, learn to explain your research and your project at different levels. By that I mean you should be able to explain it like so my mom's a doctor, so she knows a lot about this. So I would explain it to her kind of at a higher level, and then I have little sisters who really don't care about what I'm doing. So I also had to learn how to like be engaging and explain it to them. And I think that actually helps a lot because it helps you wrap your head around like everything that's going on in your project. You know, it can kind of get overwhelming sometimes. And all the research that you've done. So try and explain it to a 5-year-old and also try and explain it to an expert or to someone who might know a little bit more about that project. And then, okay, this one, really important. Don't forget about your logbook. I remember like 3 weeks before like February fair, someone like casually brought up the logbook and I was like, I have not touched that since the start of the year. It's not fun going through your calendar and finding those days that you were in lab, what you did. So definitely keep that logbook up to date. It'll save you a lot of weekends. And then the last one, ask for help when you need it. Don't get so stuck thinking that this is your project, but there's a whole community around you to help you. Don't waste your time like banging your head over one specific problem. There will be someone around you who might have some sort of idea about how to solve it. You know, like for me, it was a big thing. Like I was like, no, I have to be able to figure it out myself, or like, this is my project, I shouldn't have to put it on someone else. But really just reaching out, like, it makes others feel good that they can be there for you, which is like something that I had to learn. And also, it'll help you get there faster and your time is precious. So, and your sleep is precious. So ask questions. And I think that's all I have for you guys. If anyone has any questions about STEM, anything in general, I'm happy to answer. Thank you for yeah.
Your biggest challenge was to
Okay, well, Mr. Ellis got kind of, Mr. Ellis was the old physics teacher. I did my project in the lab in Stanford. So keeping those flies in the lab was a little difficult sometimes. I think like with model organisms, I had a lot of issues. I wanted to get my top fly. You can get them to come like genetically modified, so they might. Mine specifically, I wanted them to come like without the kind of like the precursor to serotonin, just to help and like really like magnify the impact of their depression. Those flies, issues with shipping, a lot of them died. And so I ended up having to use wild type, which is another reason I say start early. There's going to be problems that you don't expect. And I was able to adapt to that, but I do think like for me, the biggest issue was like trying to get the flies that I want and then having to accept that, okay, well, that's not going to work. What can I do to work? And that's how I ended up discovering the other stuff. So that was probably my biggest issue. And keeping them those two. Yeah. Yeah, so that was the capillary feeding assay. And basically what you do is there's these like they're like really small tubes, they're called microcapillaries, and I filled them with a sugar syrup, which is a food that the Drosophila are very attracted to and they'll normally like eat lots of. And basically the Drosophila, if I stuck them in like, so if you have like a vial, I made holes at the top and I would stick 4 capillaries in, and I would place 8 flies in the vial, and basically the software are able to like stuff the food out of the capillary. And then you just measure how much liquid has decreased since you put it in. You're starting and ending, and that's.
And hope there is. For the same.
And he's a nice senior. Now, went to in the finals for work step, went to MSET, but also invited to go to us as well.
Cool, so I just, I've been working on apologization, and as a byproduct of that, I wasn't really feeling in the STEM zone, so I figured instead of giving specifics about my STEM project. Okay, so instead of talking about specifics of my STEM project, I just give an overview of the process of going through the care, as well as just pointing towards some of the resources that I use. Okay, so first I wanted to talk about research because I think that's the component that you're working on right now. And specifically, I wanted to talk about Zotero. I think Dr. C has already talked before about Zotero, but I just wanted to show why it's so useful. So here I have Zotero open. I've added one research paper. Just I searched up Google Scholar and took first result that popped up. But okay, so I've added it to Zotero. I think you know how to do that. But now, when you start working on your research paper, what you'll be able to do is use Google Docs Zotero connector and just add your citations in text through here. So if I did something like this, it takes a while, but I'll be able to add my text citations this way. And the benefit of using this is that once you're done, you'll be able to add your sources this way. And okay. It takes a while, yeah, but you'll be able to add the final list of all your sources this way, and the benefit of using this is that it organizes all your sources in alphabetical order according to AP formatting, and then it also only puts in the citations that you actually reference. So I found that helpful. I'm not sure they'll probably come up as you're ready. Okay, next I wanted to talk about the logbook. This is a component of the project that I initially sort of didn't put much effort into. I saw it as sort of a resource for me to just put down my thoughts and demonstrate that I did the work. But some feedback that I got from Mr. Fair was that the logbook was hard to follow, and so what I ended up doing was sort of going back and changing around the formatting a little bit to make it easier for an outside reader to understand. And so I have an example of that here. This is what it looks like after I gave it some formatting. So starting with a table of contents. Okay, and then this is sort of the background of the project. I wanted to go down to here, the data entries.
So what I ended up doing was sort of almost structuring every dated entry as sort of a research objective and uh, work of its own. So I talked about introducing the purpose of that day's work, and then outlining an objective and talking about the method study. And I think that this logbook we see, it was primarily what ended up allowing me to do those myself. Okay. So for the presentation, I don't want to talk too much about what it takes to make a good presentation because I think it's kind of self-evident what a good presentation looks like. So instead, I just I put down a couple of links to good sites to go to if you need help with visuals for your presentation. So these two right here, SlideGo and Slides Chronicle, sort of give you templates to play around with in your presentations. This one is what I actually used for my December fair presentation. Essentially, it takes care of all of the formatting for you, so you don't have to move anything around. You're just sort of responsible for putting down the content. Looking back now, the visuals look kind of egregious to me, but I think that it saved me a lot of time in terms of formatting through the December fair. So definitely go to this if you're looking to prototype a presentation. Well, okay. So on the presentations, what I ended up doing was using APA formatting, wherever I could. So adding citations to my bullet points, putting table headers above the tables, and putting captions for figures underneath the captions. Not all of the judges at Worcester Fair and stuff will care about that, but there are certain judges that will, and it can only come from your favor. Okay, and then last I just wanted to talk about the specific experience of doing computer science at Worcester Fair. Last year, I think that computer science was sort of in an awkward situation in terms of judging, because if you look at the previous documents, they had scoring cards for science projects, which are like having a hypothesis and then doing experimentation, getting results, as well as engineering projects, which is where you design something, and math projects. But they didn't have a specific scoring rubric for computer science projects. So I sort of had to structure my presentations in a way that would conform to one or the other. And for me, I had to choose engineering just because I sort of designed the model. But it was sort of a strange but interesting process that I had to go through in order to get my projects scored the way that I wanted to. And it's a lot to talk about. So if you have any questions, I can answer it. Specific questions that you have. But that's all I have for now. And I can take your questions. Dr. C.
What do you think should be on a CS rubric?
Okay, so I think that something that computer scientists take into account a lot, but just isn't really appreciated, is sort of the elegance of your code. This is really wishful thinking, but I feel like maybe a review of the code itself in a scoring rubric would be helpful at assessing how a student did theirs.
Yeah.
It really is. It really is. Yeah.
Can you just go back to your logo? Or even the fact that you not really.
Okay, so looking back now, I think what I did was I sort of gave an outline of previous research that was done. And then I talked about how I could approach expanding on that research. Okay, this is-
I just wanna, since we're talking about logbooks, there seems to be a theme already, we've only heard from 2 seniors, but there seems to be a theme about the importance of the logbook. And maintaining that logbook with fidelity early on. Rather than having to like make corrections or go back and revise. If you could go back to your, say, October 26th junior self. And give yourself some advice about how to do that, and build it in so that it's doable in terms of the Mass Academy junior year experience. How would you fit that in? Like, would you kind of say, I'm gonna do this once a week, or every time I engage in the process, like what strategy might you, Erin, have used?
I think for me, it would have been a good habit to just copy paste my code into, at least copy paste my code into the logbook as soon as I made those revisions. Another word of advice that I would give is just to write with the intent of presenting it to others. The mindset that I had before, I think I talked about this already, was that the logbook should be something to prove that you've done the work. But in the specific context that was there, the judges are looking to understand the thought process that you went through while going through your work. So if the thought process is clear to you but not clear to others, then you haven't really done your job. More questions?
So you said that you copy pasted your code. How long was your code that you could copy paste it in?
Okay, so it depends a little bit on your editor. Mine, I use data spell, and so it was formatted pretty nicely from the start, but you can just copy paste all the code that you want. Some of these are quite long. Yeah, they are quite long. Oh, and then you'll see here, I just as I made figures for my presentations, I also pasted that in the logbook. That's also helpful for showing the judges the work that you've done.
Thank you very much.
You're what?
This is actually what-
All right, everyone, I am Amit, I'm the CEO of our group, the CEO. I'm Augie and I'm the CTO, I'm Anish, I'm the CIO, and I'm Henry the CMO. And our Stanton project, I know you guys are probably thinking a lot more about it than right now, but was developing a successful calculator for B2B impaired. So this is kind of a poster just summarizing all the work that we did. To start with like motivation and our home statements for this. A lot of calculators right now are really relying on visual students to turn their home. But we had a client who was visually impaired or at most of the IP. And he wanted his calculator to be useful for his GED, since he was taking that and he wanted to go to community college. So we wanted to make a calculator that had functionality of the traditional scientific calculator. Since a lot of math classes and classes in general, the calculator was really functional. So here are the requirements for that. Level 1 requirements, which were the requirements that we thought we had to meet in order for these projects to be considered a success. Some of them include that devices are started in Braille, device that the capabilities of a typical graph editor, like the TI-84, and it should contain either a Braille display or text to speech when to communicate the results to our level 2 requirements. These are all important, but they're not essential for these separate projects. And you can read some on here, like they should be able to fit inside a backpack. Just so they're mobile enough to be carried around on the campus. And it should be compatible with additional modules that we find in that. And finally, here are our level 3 requirements, which are for the next. Right, so part of the Symposium project, once you have your idea going, then you want to be making preliminary designs, so you just like basically rough second ideas. So our first one was more software based, and it's essentially just making an app that had a lot of your traditional tablet or app on your iPhone, except it would have text to speech functionality, and you could connect a Braille keyboard, which is keyboard with Braille tabs on them, and using Bluetooth. Our second design was a little bit more modular with 3 major parts behind fire, a Braille keyboard and a Raspberry Pi, which would kind of handle the input between the Braille keyboard and the processes for the equations that occur in the And our final plan was more of like a tactile calculator. It was made to be a lot more efficient, but it lost a lot of features like text to speech and more complicated functions. So for a critical design review, which was kind of a checkpoint in our STEM process, we had a keyboard which was boxed with Braille keys connected to a Raspberry Pi with enemy inputs and a design power to actually calculate the equations. And we realized that a lot needed to be changed in order to like have a successful product. So yeah, like obviously this was just kind of a checkpoint, and a lot changed from this to our final prototype. So I guess the first thing you'll notice is that there's no TI inspired. And that was something we kind of started in our iteration that we really didn't need one. And what we did instead was we utilized the Wolfram API and Python script. And basically we have the user feed in inputs into the terminal, and then those get plugged into the Wolfram API, and then obviously you get an answer out. And then we have the Raspberry Pi also use text to speech to kind of get the user what the answer is. And the keyboard actually also has Braille keys. You notice it's not on a lot of the operators that might think would be necessary to map. But the way that the Wolfram API works is that we could feed it in just like words like minus and stuff like that. And we discussed this with our client who said he would prefer to have it like this because he's familiar with all the Braille keys for letters and for numbers. But he's not familiar with all the Braille keys for things like special characters. So you know, with the times to do backslash. So we figured we just keep it simple for him and stick with letters. So yeah, just a post we look at how it works use. And then this is the one that kind of one around the kind of and we also didn't want to over all the functionality that we had some other things and we could make sure it wasn't. And kind of talking about our build process, one of the main tools that we used to develop the Braille keypad was a software called OpenVia, which basically took a JavaScript where we could kind of control what the CAD model would output. And using that, we basically streamlined our key development process that we could develop like 40, 50 keys all at once and just print them out pretty simply. And just looking at our Raspberry Pi, we originally were using the Raspberry Pi this model for me, which is one of the older designs, but we've upgraded to a 4G because it increased our speed and then also gave us some more ports that we can use for now to see how our design variants are. So you can see they met all of the level 1 requirements, which was the simple one. It met most of the level 2 ones, other than that, it's compatible with additional modules. And level 3 is about half of the requirements. Yeah, so after you finish your final prototype, done one, basically, you have a client and you deliver your products to them. And it's really important to get feedback, because then you don't really have the end of your project in general. So we got client feedback, and he really liked the real caps and kind of the simple design of it, because he could understand everything. He said typing was very intuitive because he had been working on like learning how to use a Mac program just like a normal computer. So typing wasn't too bad for him. But his one kind of complaint or shortcoming was that the product was a little fragile. And you might have noticed, but we had a lot of things connected by wires. And he said keeping track of like all of those different pieces wasn't really very good. Obviously, you're putting it in your backpack. Things can fall apart. It's not really practical. So what we decided to do was go through a summer extension and he continued working on a project because we wanted to make a better result for our clients. So we had a couple of goals that we wanted to meet in our summer extension. One was to improve the inclusion of rail caps because they tended to fall off, especially if you put them in the backpack. So we also didn't want that to happen. And we also wanted to kind of tether the Raspberry Pi to the base of the keyboard to make it more compact, and then you would also have to deal with the problem with them being coming apart in the backpack. And then finally, this was just something we didn't really have a problem with, but we wanted to work on making our Python script a little bit more efficient. And then this is kind of what our final device looks like. As you can see on the back, they're all tethered together. And you can get close to the keys, but the keys are also pretty long, so they won't fall off. And we went back to our clients toward the end of the summer to kind of discuss it with him. And he said it felt more streamlined and earlier, and he actually ended up liking the fact that the keys were super good on rather than basically had a little fun earlier to come on. And he liked the fact that they didn't bounce up and down anymore. And then he also appreciated the fact that the copy was really fast. It's just like references in the version of this product. And then again, as opposed to talking to all so you guys have any questions? If you have any questions like just talking about the engineering process in general.
I noticed that you all had, you had identified, pre-identified, like carefully, you had those. That's what I'm trying to say. You all had those. How was that figured out? And then how did you find working as a team after having completed that independent project?
Yeah, I guess I'll take this one. So how we sent you the process work was we applied for positions and people who were applied for CEOs would have to present to the entire class on why they think they were a good CEO. And then from there, talk to you and select what they thought would be good CEOs. And then those people would then form their groups based on who they thought would fit the role. And I picked these three because I hadn't worked with them all together on a project before. But I kind of understood their individual skill sets based on like documents that we have to do. And we wanted to give them and then I take this question. CBO stands for Certified Braille Letters. And it's also one of our last game. All right, thank you very much. As we transition to the next speaker.
Maya, don't take it personally.
Oh, no, everybody must not take.
So I'd like to introduce They ended up, placing at MSF, MSF, ISF. No, not placing. Well, you can keep it, that's it. You were on the final list. This past weekend, you were invited and competed at Massachusetts Junior Academy of Science. And then what? I qualified to move on to the American Junior Academy of Science in Washington, DC, so I will be over there in March. Thank you for the introduction on Thursday. So, hello, I'm Maya, and today I'll be talking to you guys about my SEM one project, titled Bacteriophage Resistance in E. coli Impacts Antibiotics. So, as you can probably tell from the title, I like biology, so I did a biology project, but I'm sure you guys have a great variety of topics that we're exploring. So, to start with some background on antibiotic resistance, I'm sure all of you have had a bacterial infection before, and all of you know that antibiotics have been medicine used to treat bacterial infections. However, overuse of antibiotics in medicine and agriculture has led to the development of antibiotic resistance, which is when these drugs no longer work and they are unable to kill the invading bacteria. This is bad for many reasons. Antibiotic resistant bacteria cause more severe and longer lasting infection, motivating research into alternative therapy. So one such promising alternative that is found for phage therapy, which uses a special virus called a bacteriophage, like this, to kill bacteria. Recent research has also shown that some bacteriophages are able to reduce antibiotic resistance. There's something known as an evolutionary trade-off. So that's where the fitness of one trait increases at the cost of the fitness of another trait. And to give you guys a closer look at how that may work in this space, I have a little infographic. So starting here, bacteria is extruding antibiotics through a protein channel outlined in red. That is one method of antibiotic resistance. However, some phages can use the same channel receptors to infect the cell, which leads to the cell death. In response to the selective pressure of the phage, the bacteria can evolve to lose this channel and thereby avoid phage infection. However, if you were to treat it with antibiotics again, since it lacks the channel, it can no longer extrude the antibiotics and therefore dies anyways. Since take the poison, die by the phage or by the antibiotic. This phenomenon led me to my researchable question, which was how can phage T4 impact antibiotic resistance in E. coli by selecting for phage resistance mechanisms that cause an evolutionary trade-off of antibiotic resistance? I hypothesized that if E. coli evolved resistance to phage T4, then the bacteria will display a decreased resistance to two antibiotics, colistin and vancomycin, and increased resistance to the other antibiotic ampicillin due to modifications to the phage T4 receptors, outer membrane protein C, and lipopolysaccharide, or OPC and LPS. Those are just some components of E. coli's outer membrane. I may refer to them every now and then, but please let me know if you get confused as to what they are, and I will be clarified. So to answer my question, I first started by determining the minimum inhibitory concentration for my wild type E. coli for the three antibiotics I mentioned before, vancomycin, colistin, and ampicillin. So the minimum inhibitory concentration for MIC is the smallest dose of the drug needed to stop bacterial growth, and it's one way of measuring antibiotic activity. So then I took my E. coli and I exposed them to three different bacteriophages to evolve resistance. These phages were phage T4, which is my experimental phage, and phages T2 and T4R, which were my. I then confirmed the phage resistance with the cross-shade test, and then determined the minimum inhibitory concentrations for the mutant E. coli strain for the same three antibiotics before. Finally, I compared mutant and wild type MIC to see the change. So results, yay! Starting with vancomycin, here's a figure showing the mean MICs on y-axis and the E. coli strain x-axis. A little for you, the purple bar, the wild type bar, the two green bars in the experimental, and the four blue bars are the. As you can see, the controls don't experience any change in their MIC, which indicates unchanged resistance to vancomycin after phage exposure. But we do see a dramatic decrease in the MICs for the two experimental strains, indicating significantly decreased resistance to vancomycin. So this supports the hypothesis where I stated that the MIC for vancomycin would decrease after exposure to phage. Second antibiotic, yay, the colistin. So there's a lot more variance in all the mutant strains for colistin. Notably, I saw a significant decrease
decrease in MIC for strain T4S3 experimental, indicating increased resistance to listed and supporting the hypothesis. I also saw an unexpected increase in the MIC for one of the control strains, T2S3, which indicates increased resistance to listed. So this is something I found very interesting, and I was not really focusing on the control strains. But this could be due to the fact that page 2, which was the page for the strain, uses different receptors to page 4, notably bottom breaker to F and LPS rather than bottom breaker to C. And finally, with penicillin, we see that each of the mutant strains experiences unchanged or decreased MICs compared to the wild type, indicating unchanged or decreased resistance to the antibiotic receptor. So this contradicts the hypothesis, and I had originally predicted the MIC would increase after phage exposure. This hypothesis is based on a study that indicated that the absence of OMPC at the receptor conferred resistance to a class of antibiotics called beta-lactam antibiotics. So penicillin is a beta-lactam antibiotic. However, after seeing these results, some further research revealed that ampicillin is somewhat of an exception to this rule, so that may explain why we see these results. So what do these results mean for numbers? The first, we see that the development of resistance to H4 significantly decreases resistance to vancomycin and penicillin, which partially supports my hypothesis. So double concept. Additionally, that increased resistance to penicillin I saw in strain T2S3, increase in MIC I pointed out, indicates the fitness of H choice for this process. And what we observed was called an evolutionary trade up. So rather than the fitness of two traits switching off, the fitness of two traits both increase, which manifested itself in cross resistance to both bacteria phage and to the antibiotic, which obviously can be very bad in clinical settings, as that leads to the multi-drug. I also observed decreased growth rates in the T4 resistant strains during the experimentation process. So you can see that in this picture here to the right, this is an average plate with all of the bacteria strains I cultivated during my research, and these three down here are the phage T4 resistant strains. So after 1 night of incubation, you can see that they're a lot more spotty than the other strains. They grew a lot slower. I think this is another effect of the phage resistance as the modifications to those receptors, OMPC and LPS, could have caused the bacteria to function at a lower level and therefore slow down. Finally, using E. coli K12 and phage T4 as the model system, it's pretty reasonable to assume that similar phage bacteria relationships exist in other bacteria, specifically more problematic ones like Pseudomonas aeruginosa and MRSA, which will be the pathway to potential treatments. So there's a lot of ways I can extend the study. First, I can examine mutations and E. coli mutant strains to see specific reasons behind why the MIC is changing. I can experiment with other antibiotic or phage combinations. There's many phages that are E. coli specific and many antibiotics that correspond to their receptors. I could also do multiple iterations of phage exposure to see how phage resistance and antibiotic resistance evolve over time. I could also use antibiotic resistant bacteria in the beginning of the project as the one I used for wild type due to safety limitations in the Mass Academies lab. And finally, potential applications for this research include in synergistic treatments with antibiotics, which include both phages and antibiotics to together to treat multi-drug resistant infections with the evolutionary development. Thank you to Dr. C for his guidance in this project. And that is it. Thank you guys for your attention. And if you guys have any questions about either my project or someone in general, I'm happy to. What do you think was the hardest part? There was definitely a big knowledge gap for me in the beginning, just a lot of things more specific, like biological facts are not taught in school, so I had to do a lot of independent research. I think also planning was pretty difficult for me, since I was working with bacteria. You have to take into account like incubation time, how long it's going to take you to do the assay. And then you have to incubate it overnight, so you have to like really strictly plan out when you're going to be in the lab and what you're going to be doing. So I found that to be pretty challenging because I didn't really start doing that until kind of late in the STEM 1 process. So I recommend you do that early if you're working with bacteria or other model learning.
Well, I think, consider doing this? So how do you like, you know? Talk about that.
So the specific strain of E. coli I use, K12, is non-pathogenic, so it doesn't actually cause illness. So that's one way I got around the whole danger aspect, because yes, E. coli can cause illness, certain strains of it, so doing research, I guess, into what model organisms would be safe to use is definitely an important part of the biology.
Do you have any major setbacks while you're experimenting, but like kind of change the path of the process?
I can't say I remember any extremely bad ones that like fundamentally changed my project. A lot of it was just like planning, knowing, or like if the test went wrong, having to make up for the lost time. Some of the materials were a little tight, so like very computer was just plate thing with a lot of development, it's on a 96 plate. Me and a couple other students were all using them, so we kind of ran out, but that was not as big of a setback as I anticipated.
How long did the experiment take until?
I think I started preliminary data collection in late November. I didn't formally start taking down data until around mid to late this summer. Because a lot of, specifically, you know, for bio projects, a lot of it is learning the techniques to use, so sterile technique, how to set up this test, how to grow bacteria. That took me a while to learn. So yeah, I think 82 months. Sorry.
You have any like tips for like presenting, because like you speak very confidently.
Thank you.
So like, how did you, I guess, train yourself to be confident?
I do have the advantage of having given this presentation about 25 times now. So definitely practicing a lot, knowing what you're going to say, which slides are going to come next, without having to look back all the time. Since depending on the format of the fair, you guys may be in person, hopefully. My fairs were all online, sorry. So I could see my slideshow through Zoom, but that may not be the case for you guys. Definitely do research anticipating what questions you're gonna get. So like common questions for me may include, why are you using this antibiotic? Why are you using this bacteria? Some good techniques are to stockpile slides at the end of your presentation to answer these questions. So I was, as you can see, quite prepared. So knowing your background knowledge thoroughly, knowing like all the ins and outs of your project. Some questions you can't really prepare for, but having that practice will definitely help you speak more confidently.
Questions. Do you have advice when somebody asks you a question and you don't know the answer?
Just say you don't, like, it's okay to say you don't know the answer to a question. It's better to admit like I don't know this, and then give like your best guess, and then maybe even ask the person who asked you a question, what are your thoughts on this? Instead of trying to like, pardon my unprofessional language, BS your way around the answer, because they can tell and it will make you look very silly. So it's okay when you don't know.
Thank you.
I just slightly going with all the years. Oh, slightly. You know, it's a street view. Yeah, so much better. Well, it's great. It's this is no, like. Where you guys at now? No, that's.
Very. Worst place.
Right, have a good night.
Oh.